Many software companies have a core underlying belief that effective decision-making needs to be backed by meaningful data. And software systems are no different. When a customer asks for a requirement, the technical team needs to be able to deliver the requirement with an implementation that matches the customer's expectation. So they want to be able to measure in an effective way that the feature that's being added adds the functionality that they care about. And this matches what Lord Kelvin said in the late 1800s when he mentioned that to measure is to know. I mean, we need a way to concretely evaluate the features that we've added to our system, make sure they perform as expected and are correct. And requirements validation plays an important role in this process. Being able to validate a requirement is also extremely useful for a technical team, because if you have a concrete understanding of how your customer is going to evaluate your feature, you can evaluate the feature yourself using the exact same methodology while you're creating it. And it turns out in practice, measurable objectives tend to be easier to achieve than unmeasurable objectives. One other nice thing about capturing the rules for how you're going to validate your requirements is it gives you a way to make sure that the requirement is clearly and concretely stated in the requirements itself. Because if you can't come up with a concrete validation process, it might mean that you need to go back and step through the elicitation and analysis phase to make sure that you're actually capturing the requirement in an effective and clear way. Finally, validating requirements makes it so that the technical team and customers are on exactly the same page at the end. What you want to do is you want to be able to find problems with the validation steps during the requirements gathering process rather than during the product delivery process that could happen years later when all of the development is finished on a project. Right, so this gives you a way to really capture these kinds of errors really up front and help the teams get on the same consistent page. So some requirements are really easy to validate. Right? So for instance, say you have a functional requirement that the list should be sortable on both columns. All you need to do is sort the list on both columns and make sure that it actually works. And that's really relatively straightforward. But other requirements can be really challenging. For instance, the system shall be performant, or the system shall be usable. What does that actually mean? How do you measure that? What is performant, and how do you measure usability? These types of requirements are really challenging in practice and are often need to be restated in more concrete terms so that they're meaningful for the development team and give them explicit goals to try to meet. So let's step through a concrete example now where we look at how we can make these requirements more meaningful for development teams so that they have explicit targets that they can work towards. A common requirement is that a system shall be performant, and that's an easy requirement to add to the list of quality attributes that you care about for your system. But what does that actually mean? How can the development team actually measure the performance of their system and know that they're hitting it and achieving that requirement if you're just saying should be performant? Let's break down performance and take a further look at how we can split this requirement out in a more concrete way to provide a development team with more measurable goals that they can validate against. So let's take a look at performance. So performance can mean many different things. One type of feature you might think about when you're thinking about performance is time. And time makes sense because time captures how long it takes for something to happen. Another performance limitation for systems is in terms of storage or space. And when we think about space, we might want to split this up a little bit further as well. When we think about the space occupied for a system, we might think in terms of memory, or we might think in terms of disk. And when we think about this concretely, we can actually attach concrete numbers to both of these values. You can say, hey, the system should never use more than 100 megabytes of memory during its execution. Or the system should not consume more than 1 gigabyte of disk, including its caches. These are both extremely measurable values that the development team can think about. In terms of time, there's lots of other values we can think about as well. So the first one, and the easiest one to think about, might be response time. So response time would capture how quickly the system can respond to the user. So you can say, hey, the system shall respond to a user's input within 150 milliseconds. And that gives the development team something that they can measure explicitly against. You could also think in terms of throughput. So throughput measures the amount of users per second, or the number of transactions per second that a system can handle. But there are different kinds of throughput. So you might say, hey, we care about peak throughput or off-peak throughput. So in peak throughput, you might say, hey, in the middle of the afternoon, the system should be able to handle 50 users per second. And in off-peak times, when the system is maybe doing other transactions in the background, you might say, hey, the system should only be able to handle 10 transactions per second. So you can go to a lower threshold because the system is doing other things at the same time. And again, all of these leaf nodes give the development team concrete values that they can measure their system against to validate that they've actually delivered the performance targets that the customer actually cares about. And by putting them in these concrete terms, it also forces the customer to clearly define what they mean by the system shall be performant. So this gives the development team a way to concretely push back on the customer to make sure they're completely specifying their desires for the system.